One more speaker, Yana Valachovic. Yana was raised on the North Coast among majestic oaks. Since its 2000, she has been the University of California Cooperative Extension Forest Advisor for Humboldt and Del Norte counties. She has been studying Oregon white oak and California black oak ecosystems for the last 2 decades, and her work has led to new permitting options to help incentivize and legalize oak restoration in the California forest practice rules. Yana returned yesterday from New Zealand, where she was overwhelmed by seeing all our plants and trees there, from the plantation conifers to the wildlands where many of our horticultural plants are from, like flax, hebes, and cabbage palms. Welcome, Yana.
Well, good afternoon. Thank you for the invitation, and welcome to part 2 of the North Coast Oak story. I'm going to give you a little bit of a whirlwind today because I've been working on this field for a long time, and I've got a whole lot of projects that we've been putting together, which includes some of which we heard a little bit earlier today around characterizing conifer encroachment based in its age and stand structure and biodiversity. So lots in the biodiversity front, Hugh, that we could talk about. We've also done a project that's looked at evaluating the restoration effectiveness of both the Natural Resource Conservation Service and U.S. Fish and Wildlife Service restoration programs along a whole bunch of fronts, including oak health, forage response, and wildlife response. We've got some ongoing projects looking at oak regeneration and the effects of cattle and deer grazing on oak seedling success. We also are wrapping up a project looking at the water demands of conifer encroachment. And the most fun stuff that we've been working on lately has been looking at wildfire impacts in these stands that have had restoration. And so that's where we'll wander to at the end of this talk. So a lot of colleagues, both for the University of California, Berkeley, Humboldt State, and a whole range of landowners and agencies. So it's been a real fun journey. You can open the door with one project and you have no idea where it's going to land several years later. So what I want to talk about today is really California's dueling identities. And the question I have, and I'll tell you that I'm a registered professional forester, and so I think about a lot of what we can do based on a permitting framework. And the dueling identities in California are we a conifer state or are we an oak state? And it depends on who you talk to and how you think about it. But really, our conifer framework is what drives how we think about permitting and policy options and fundamentally restoration. And when you look at the oak species, it really underpins a big challenge we have in identifying who we are and what our values are. So I'm going to frame that in that way and then talk about how we think about challenges of encroachment related specifically to conifers, and how do we think about these broader issues. And what, I'm an extension agent, which means that I do a lot of science translation to policy, and really the gold standard is being able to create new options for management, move beyond best practices to be able to help in a regulatory framework to be able to help landowners achieve their goals. So that's where I get the most excitement in this work. When you think about these majestic stands of oaks, it's really hard to go back past, our lifetimes to be able to think about what these stands have looked like through time. I think we broadly understand that floristically they have a huge diversity, and within that there's a whole lot of wildlife species that really utilize these stands. What's interesting is that this process of encroachment is kind of silently happening across much of their range, and when you talk to people throughout California, I think most people think that these species cohabitate the same areas that conifers do, and that they are thriving in those environments. And I will say, in my framework, I think they're fundamentally just surviving. They're not thriving. And we have kind of become a culture to this idea that they can coexist. And I'm just going to tell you that they don't really coexist very well. So in our work, we've been trying to do, as Lucy said, be able to characterize this process of encroachment, and we framed it in kind of an early phase where there's young seedlings of primarily Douglas fir getting established, to a mid-stage where you don't see the conifers fully piercing the oak stand, to this later process on the right-hand side where you can see the oaks are now overtopped by those conifers, and not only are they leaning for light, but if you look at the understory at this place, we've moved from a condition where you have great floristic diversity to something where you have almost no herbaceous plant life left in these stands. So we've got a lot of data, and I'm just going to give you some of the highlights here. And one of the questions that's relevant is are these trees multi-stemmed? And why would multi-stemmed trees be of interest to us from a policy perspective? Well, they're interesting to me because that means that those trees have been there a longer time than if you date them and you core them, that just says that's the age of that stem. But if they're multi-stemmed, that tells you that's the age, that there is likely a mother tree before that and maybe a mother tree before that. So it gives you a sense that this tree has been in that area for a longer time. And so what we see from our data is that there are about 30% of the trees we've cored have been multi-stemmed trees. And that led us to some pretty big revelations. We saw an earlier version of this in Lucy's talk of really trying to think about this age distribution issue. And there's a really fascinating piece of information. This is a little more detailed version than what Lucy gave you, where we've got proportion of establishment based on date. And this was not a study that we were looking at for trying to get the oldest tree out here, but we've got some trees that date back to the 1600s. And you go along here, and then all of a sudden we get this huge pulse of regeneration from about 1850 going forward that declines after about 1920. Now, none of us were here at the time to know exactly what happened, but we've been speculating that this really looks like a release action as opposed to a major wave of regeneration. So what we've hypothesized, and there's some interesting things when you think about this. So in 1920 is the time period when we move in the state of California to prohibiting the sale of game meat. So deer are game, and in 1920 we start changing how we think about deer, and that coincides to basically the end of this release, as we're calling it, or establishment of oaks. So what we think happened here is that when the settlers and the miners came to California, there was a huge harvesting of the game species to be able to feed those folks. And what that did is it took the pressure of browsing off the oak species and enabled the oaks that had been hanging out there trying to sputter in the understory to be able to respond. So we have old oak trees. We have a big pulse of them that come from 1850 going forward to about 1920. And then we don't have a lot of establishment since then. What I'm not going to show you, and I think is relevant to this, is that we do know that these trees and these stands are still producing a lot of acorns. But what happens is they regenerate, but they don't make it to sapling size classes. So we know that we haven't stopped their regeneration capacity, but they're not able to hang on and stay and become full trees. So the good news, meaning from a restoration perspective, is if we can start to release those legacy trees, we'll be able to recruit more oaks through time. So the question I have also had as a part of this was like, well, what is this time period of conifer codominance? How long does it take for these conifer trees to basically become neck and neck as the same height of those oak trees? So our research looked at 10 sites across Humboldt, some of Mendocino, and a bit of Trinity County, and these are coded by basically wet to dry, with the brighter colors being the dry sites of the xeric sites. And what we see is that conifer codominance in white oak occurs between 20 and 80 years. That really surprised me, I'll just be frank, to say that this process can happen really quickly. And so that gave me more of a reason to thinking about why we need to apply a restoration framework. Black oak, it's about the same, a little bit tailing, again, to the slightly older encroachment process. So what are the effects of conifer removal on restoration? Just a couple of highlights from this. What we can see is that so this is diameter against crown area density, and we can basically see, I think one on the left, I haven't looked at this for a little while, treatment versus control. I think these are both, I think that's black oak and this is Oregon white oak. And we definitely see that we get a crown response as a result of restoration. It's not huge, but we do know that these trees are capable, once the conifers have been removed, to be able to respond to these treatments, which is great. Now, we're also curious if we could detect that in radial increment growth. And so I don't know if you've ever looked at oak cores or if you've ever cored an oak. I highly recommend you actually don't core an oak. I think we broke about 15 borers in our primary research project, so a lot of a lot of chiropractic work afterwards, shall we say. So actually, let me back up. So this is basically the core from the last 10 or 12 years or so. This is from a control site, and what you can see is that growth is slowed here during the last increment period. And so these are how we read these oak cores, different from conifers, of course. But when we compare that to a core that has had it comes from an area where restoration has occurred. Look at this, look at this radial increment growth. So what's interesting about this site to me is that this growth occurred even during the 2015 and 2016 drought. So these trees are able to respond even during droughty conditions. So kind of cool to know that these trees have that capacity. So then how do these oaks fare in the face of wildlife, or face of wildfire? So I just want to take you down one little anecdotal project we've been working on. So this is the August complex. It's the 2020 fire that was the million-acre fire. And conveniently, the fire happened on its biggest run to blow through some of our research projects. So we had pre-treatment data, which is rare, and then we were able to look at how survival was impacted in relation to this big, huge run that the August fire did. So I'm going to start with a picture tells 1,000 words here. So the treated site is on the left. This is where we had done the restoration work, and this is where no work had happened. And this is after the August complex. And you can see there's essentially almost no survival in the area that had not had treatment work, but we had pretty good survival overall in the area that had work. And when you think about, what does restoration mean? How do you apply it? What are some of the different treatments that people use? What I want to say is that when you leave fuels on the ground, it makes a difference. And so I'm just showing you now 3 different examples of, in one site we had a lot of manzanita, and it was in addition to the fir, and so this was piled and burned with mastication, so that's what's showing on the left. The one in the middle is where the conifer trees were just basically cut and lopped and scattered and left to decompose. And then the one on the right is where there was more fir overall encroachment, and there was piling and burning and mastication that occurred. The big take-home is when there's a big difference between the treated area and the post-fire environment. So what we saw, basically, is that if that cut material was left on site, we had mortality in the oaks. So you leave a lot of surface fuels, you're going to get a longer residence fire, and you're going to be able to impact those oaks more substantially. So thinking about restoration in terms of future fire or next entry or whatever you're going to do, it's not just a matter of taking away the competition, it's also a matter of taking away those future fuels. That's at least what I take home from this small project here. So along the lines of this broader sets of research questions, I've been working with the state legislature as well as the California Board of Forestry and Fire Protection, and we, using this data, basically developed a comprehensive set of new changes to the forest practice rules to enable landowners to do this work. Because prior to this, if you cut a conifer, what did you have to do? You had to plant a conifer. So restoration doesn't necessarily work if you're dealing with an invasive species into these sites, because conifers have the gold star when you think about it in California's regulatory framework. So here's just an overlap of where we see Oregon white oak and California black oak in relation to Douglas fir. So they overlap, the ranges overlap, and so just to take you down the nerd cycle of policy, the way we classify things in the forest practice rules are we have Group A and Group B species. Group A are all the conifers, Group B are all the hardwoods, and we have language that basically says you cannot change the proportionality of those two. So in other words, you can't take all the high value stuff off and leave the lower value trees behind, which makes some sense. You can't cut and run, but when you have an invasive encroacher, that's where the equation gets more complicated. So what we had to do was fix several pieces in the rules related to both stocking, proportionality, conversion, a lot of ways that the forest practice rules are framed. And then this was done, now I'm trying to remember, almost 6 or 7 years ago, and there's been about 35 permits filed to date. And then last year, working with Assemblymember Wood and Cal Forest, we were able to further tweak the restoration framework, which I think is going to make this much more feasible and much more usable for landowners and their forest managers to be able to do this work. So what is coming, and I'm looking at a member of the staff for the California Board of Forestry and Fire Protection, is some additional changes to the exemption, where we'll be able to remove conifers at a greater size and diameter, which is really important because if you leave the conifers on site, they continue to produce seed, and the restoration is not effective because we know that we're just going to continue to have reintroduction after reintroduction of Douglas fir into those sites. So what you'll see briefly here, and if this is of interest to you, basically what is in green were the previous rules, and what is in brown is what is going to change. This also opens up this work to happen in the southern subdistrict, which is really important for the range of these oak species. So, in conclusion here, basically we've given legal standing for the deciduous oaks. We've brought statewide attention to the issues. We've demonstrated that restoration works, but we need to be thoughtful about next entry in the plan for future use of prescribed fire, as well as the potential for wildfire. And this has really created a legal pathway for merchandising the cut conifers, which is super exciting to me. So thank you for your attention, and I hope you all have a wonderful conference. I guess I have time for a question or two, I don't know, or not. Or I'm in between now and your break, so I see one back there.
Hi, thank you. Really interesting talk over here on your left. Over here.
Thank you.
So I was curious about, you showed the release of oaks at the sort of during the pioneer era, late 19th century, but yeah. I'm curious how, because tremendous numbers of cattle were introduced at the same time, and how that plays into the whole picture.
Yes, grazers versus browsers. That's one of the really important things to think about in this space. So what you have with cattle is that they are grazers and sheep are browsers. And so you would see something different also based on where those patterns of where those grazers and browsers are located. Deer are also browsers. So it's a little messy, but in relation to your broader question, so we've been doing a number of exclosure projects where we've been trying to exclude both deer and cattle, and we do not see effective regeneration when cattle are present, but we do see an impact on regeneration when deer are present.
All right, thanks.
There's one over there.
Yeah, you mentioned, obviously the 1850 transition has to do with the gold rush and everything, but it struck me that another thing that could be considered is whether the suppression of indigenous burns was a contributor to that change also.
Sure. I mean, there's a lot of variables that are in effect here, but there's some level of response and change to a variety of things that occurred at that time. So I'll stand, in that, I think there's a multitude of factors, but I just really want to suggest that we need to think more clearly about what deer play of a role in these ecosystems. All right. Thank you very much.